Welcome back. Here we are, I think, in our last video for Chapter 8, we hope. Hopefully I can move a little bit faster than I've been going because it's pretty much the same idea with one new little twist at the end that hopefully you're okay with here. But let's do this time conversion. Now, again, you could probably do this in your head, and that's fine if you can, if you know hours and minutes. But to stay consistent, I'm going to go ahead and show you what we would do if we were doing this the other way. We would match up our units here and here, multiply them out, 1 hour is 60 minutes, and have the solution 120 for the first one. Got a little bit ahead of myself there, sorry about that. 4 years is equal to how many days? Well, okay, I got a little picky here. If we look back here, let me refer back to this here. Okay, you've got that for this part of the test, and here's all the time. And on this chapter, on this section, they give you all kinds of time units. I would like to just point out that this part right here, they're just using 365 days for a year. That's fine, but the problem is they don't account for leap years if they do that. You see, a year is actually not 365 days, it's 365 days and 6 hours. So every 4 years you have 6, 12, 18, 24. You have 24 extra hours. That's how long it takes for the Earth to rotate, go all the way around the sun. It's a little more than 365 days, which is why you have to have that leap year day in there. So with that in mind, when I originally made this PowerPoint, instead of doing 365 days, I did 365.25, which is 1/4, because 6 hours is 6 out of 24. It's 1/4 of a day. So if you wanted to do like 20 years is how many days, well, if you didn't do the 0.25, you would have to count how many 4s are in there and add an extra day for all the leap year days. More information than you probably wanted, but that's why I did it this way, and that cancels out just like we've been doing. 4 years is actually 1,461 days. Okay, try it without the 0.25, you'll get 1,460. And then you'll think, oh, but there's a leap year, so you have to add 1 day. Voila, you've got it. So time is pretty simple for you. If you get a weird one, just set it up and do the canceling out, days and hours there. Now this is a double one here because you're going from days to minutes, and unless you know how many minutes are in a day, you'd probably have to do 2 steps like I did here, all of which is on your chart. Multiply 24 times 60 there, and you get how many minutes in a day. Or if you want to know how many hours in a week, again, I'm telling you the same thing here over and over. Use the labels to do the work for you. And you get, you got 168 over 168, which is 1 week there. All right, let's go on to the last part. I think we can wrap this up here in a couple of minutes. This is on your chart, I believe, at the very bottom. All right, if you have to make temperature conversions from Fahrenheit to Celsius, Celsius is the metric form of temperature, and Fahrenheit is ours. So if you're going to go from Fahrenheit to Celsius, either one of these works fine. People usually use the decimal one because it's easier to put in your calculator. If you're going to go from Celsius, or if you have Fahrenheit and you want Celsius, you could use this, either one of these right here. People usually use that one, I think, because they get afraid of the 5 ninths there. I don't care which one you use as long as you can work it out here. So let's take a look at a really interesting thing here. Again, for me to just say why the metric system makes a lot more sense as far as numbers go. Watch what happens here. 0 degrees Celsius to Fahrenheit. Okay, well, what we would do is we would take the 0 and we would plug it into the formula there. So here's the formula right there. So we're just going to replace that with 0. We're going to do the math, and 1.8 times 0 is that. So that would equal 32. Now, do you know what happens at 32 degrees? Did you say water freezes? If you did, you're right, it does. So, just to make a point here, what makes more sense in a number system? That water would freeze at 32 or 0, which it does in the metric system. I don't know about you, but it makes more sense that to me that it would start freezing at 0 degrees, because then anything negative would become frozen. But that's just a thought. Anyway, let's make sure you can do another one that's just a regular one, like 37 degrees. If you put that in your calculator, okay, 1.87, what I did here, if I went too fast, I took that 37 and I replaced it in for this C right here. Did that work right there? 1.8 times 37 plus 32, that came out to be 98.6 degrees Fahrenheit. Right there. Okay, so let's wrap it up with the last page, and let me show you one more thing. You've got these two problems here. Okay, you're going to do, you want to do 212 degrees Fahrenheit, and you want to turn it into Celsius. Okay, so again, I like to take that, most people like to take it, put it in there. So you're going to do 212 minus 32. Now, you need to practice this on your calculator and be very careful. Because when you put this in the calculator, essentially you need to imagine that these two numbers are in parentheses. An easy way to do it on your calculator is just to put in 212 minus 32, hit your equal sign, and that's division, and then hit divided by 1.8. And that'll get you to the answer there. And if you do that correctly, you'll get 100 degrees Celsius. Okay, now, this will be the last thing I say about this, but do you know what happens at 212 degrees Fahrenheit? Did you say water boils? Because it does. Water boils at 212 degrees Fahrenheit or 100 degrees Celsius. So, here's the conclusion. At 0 degrees Celsius, water freezes. At 100 degrees Celsius, water boils. Now, what makes more sense? 0 to 100 or 32 to 212? I'll let you decide. It's not like we're going to change anything anyway, but it's interesting to know. There's just a lot of sense to the metric system. All right, let's do one more real quick here. If we did 77 degrees Fahrenheit to Celsius, we would put that in your calculator. Again, treat it as though that's in parentheses and hit equals before you hit divide. If you do that, you should come up with 25 degrees Celsius. So double check me on that, see if you can get that to work in your calculator. And guess what? That's the end of chapter 8. So good luck on your homework. Bring your questions to class. We'll see you soon.